Richard James will begin these tutorials on ratios and variations, and I will begin with the first one, Ratios and Variations Tutorial Part 1. Before going into the actual problem solving activities, let us take a look at what a ratio really means. Consider the following ratio. That ratio is given as 2 to 3 to 8. If this represents the manner in which a certain sum, object, or number of items is shared, then an excellent way to consider the ratio is as if it represents the total number of equal units in which the total is divided. So here we have 1, 2, 3 shares. However, this one gets 2 units, this 3 units, and this one 8 units. Therefore, the entire amount is actually equal to the sum of those 13 units. So this individual's share will be equivalent to 2 units. This individual's share will be equivalent to 8 units. And it is very important to note that the entire amount or sum or portion of the object, the entire sum, is represented by 13 units, which is what we get after adding all of these. So we have 13 units. So the entire amount is represented by 13 units. The fraction of the whole that each gets may be determined by dividing the number of units in each share by the total number of units. Therefore, let us say we need to determine the fraction of the entire sum that this individual gets. That fraction may be found by taking the number of units that this one gets, which is 2, and we may divide that by the total number of units. That turns out to be 13. So the first one will get a share that is equal to 2/13 of the entire amount, and this one will get a share that is equal to 3/13 of the entire amount, and finally this one will get 8/13 of the total. So that is how we will determine the fraction of the entire amount that each one gets. And we will do that by taking the number of units that that individual gets, and we will divide that by the total number of units. From what we have said before, it is clear that the numbers in the ratio represent the number of units that a whole may be divided into, but we will go straight ahead and state it anyway. So we have the ratio no doubt right here, and we will go straight ahead and state it that this one gets 2 units, this one will get 3 units, this one gets 8 units. It is obvious, but we are taking note, or we are at least mentioning it or placing it on the slide that we may make a reference to it as we progress. Let us say that in a particular situation that is governed by the same ratio the individual, which is this same ratio, the individual with 2 units gets 12 marbles. How many marbles will the one with the largest share get? So we are saying, or the question could have been stated in another way. The one with the smallest share got 12 marbles. What will be the share of the one that got the largest number of marbles? Or what is the size, or how many marbles will the one with the largest share get? So that may have been another way to state the problem, because I'm just making use of the fact that these two that we have here, being the smallest number in the ratio, is representing the smallest share. And of course we know that this 8 is the largest share. So the problem is the one with 2 units. That one has 12 marbles. So how many marbles does the one with 8 units have? How do we tackle that problem? The largest number in the ratio is 8. We therefore need to determine the number of marbles that are represented by 8 units. This may be determined by simple common sense, because common sense is greater than mathematics. Therefore, we should not be afraid to use our common sense. We will take a look at it on the next slide. So let us take a look and kind of remind ourselves what we will be going to the next slide to do. The largest number in the ratio is 8. We therefore need to determine the number of marbles that are represented by 8 units. That is what we need to do, but not without the information that 2 units get 12. And we need to know how many marbles does 8 units get. Let's go straight ahead to the next slide and determine that. As stated before, 2 units are represented by 12 marbles. All that we need to do is determine the number of marbles that 8 units represent. The best way to look at it is to determine the number that 1 unit represents. So we have 2 units being responsible for 12 marbles. We need to determine how many marbles what number of marbles is represented by 8 units. And as I'm saying now, just agreeing with the statement that we have here, the best way to look at it is to determine the number that 1 unit represents. So let's go ahead. 2 units, 12 marbles. So how do we know, or how do we determine the number of marbles represented by 1 unit? It does not take much to see that 1 unit is represented by 6 marbles, which is what we get when we divide 12 by 2. Therefore, 2 units will be 12. Therefore, 1 unit will be 12 divided by 2, which is equal to 6. As a matter of fact, if this is 1 unit, if you multiply 1 unit by 2, you get 2 units. So if we multiply this by 2, we get 2 units, and at the same time multiplying 6 by 2, we get 12. So 2 units will be represented by 12. Not difficult to see that 1 unit is represented by 6 marbles. And as the tutorial goes along, some other steps will be made clearer, because we will take a more detailed look at the problems that we are about to solve. So 1 unit is 6 marbles. 8 units must be 8 times larger than 1 unit. So take 1 unit, multiply by 8, you get 8 units. And what is the number of marbles represented by 1 unit? 6. Therefore, in order to determine the number of marbles represented by 8 units, we need to take the number of marbles represented by 1 unit, which is 6, and multiply that number by 8. So 8 units will be 6 times 8, and that will be represented by 48 marbles. We may look at the problem in another way. The ratio tells us the proportions in which the marbles are shared. The numbers of marbles must be in a similar ratio. The first number is equivalent to 12 marbles. What is that statement saying? This tells us how the marbles are shared. 2 to 3 to 8. Therefore, we have 12 marbles being revealed by the one who has 2 units. Also, well, let us say that the marbles associated with 3 units and 8 units are hidden, and we need to determine what number of marbles do these two represent. The numbers of marbles must be in a similar ratio. Therefore, the ratio that we have, 2 to 3 to 8, must be the same ratio as 12 to something to something. So the numbers of marbles must be in a similar ratio. The first number is equivalent to 12 marbles. What do we do to find the other 2 numbers that will cause this ratio to be equal to this ratio? Because they have to be equal. How is 12 related to 2? Or how is 2 related to 12? To get from 2 to 12, we need to multiply by 6. So 2 is related to 12. To get from 2 to 12, we multiply by 6. So we say 2 times 6 is equal to 12. We will therefore do the same with the other numbers. We will multiply 3 by 6 and multiply 8 by 6. So what will we do? We will say, to get here, 2 times 6, 12. So we need to do 3 times 6 and 8 times 6. And these are the numbers that we have, and they will be 18 and 48, as we have mentioned them right here. The largest share is 48 marbles. It cannot get more difficult than that. But, along with common sense, we will apply some mathematical principles in solving the problems. And let us begin. A certain amount of money was shared among 3 individuals in a particular ratio. And we have the ratio right there. The letters that represent the three persons are written in a ratio, as we have them right here, in anticipation of the ratio that will be supplied by the statement of the problem. The ratio supplied is 2 to 3 to 8. There we have it. So we are saying that A gets 2, B gets 3, and C gets 8. And this is the same ratio that we used for our introductory statements. Remember how to find the share that each gets by finding the sum of the number of units that are represented by the numbers in the ratio and divide each number in the ratio by the total. That is kind of a mouthful, but because we have done it before, it should not be so difficult. Nonetheless, we will continue to explain in order to make it clearer. Remember that we found the sum of the numbers in the ratio, and each share will be found by doing what? Dividing the number of units that each one gets by the total number of units. 2 over 13, and the other 3 over 13, and the other 8/13, as we did before. So this is the fraction of the entire sum that this one will get, and this is the fraction of the entire sum that this one will get. This is a fraction of the entire sum that this one will get. The fractions represent the respective shares of A, B, and C. They represent shares of a sum of money that we do not know. Let us call that sum of money X. Each will therefore represent a fraction of X. We will multiply each fraction by X. Here are your fractions, and we will multiply each one by X. So this one will get 2 over 13 of X, 3 over 13 of X, 8/13 of X. There we have them. And we are placing subscripts to show which is associated with which. But I'm not so sure that it is completely necessary, because they are in respective orders. So we know that the first one is associated with A, the second with B, and so on. A does not play any role in the problem. We are told that C receives $120 more than B. Therefore, if we add $120 to B's share, the result will be C's share. So A does not take any part, and C gets $120 more than B. Therefore, if we add $120 to B, then the result will be the share of C. One great problem that students have interpreting this problem is that they interpret the problem in such a way that they conclude that that $120 should be added to the share of C. But do not forget that we say that what? Leave this out. Leave out this 120. And look at this now. C receives more than B. C receives more than B. Therefore, you will have to add a certain amount to B's share in order that you may get the share of C. And that is what we have done right here. In order to find the sum of money, which is X, we will solve the equation. So we have an equation to solve, and we will go straight ahead and solve that equation, which is this one. B's share plus $120 more will give you C's share. And we are about to solve that problem. Let us solve the equation. Our first step will be to eliminate those denominators by multiplying by the common denominator of 13. So the common denominator of 13, and what do? We may just go straight ahead. 13 will cancel with 13, 3x. 120 times 13 will go next. Then we say 8x over 13 times 13. This cancels with this, and the result is 8x. So let us write it down. But before we write it down, let us take a look at it under the microscope so that it can be clarified for those students who want to take a second look at it. So we take the 3x over 13, multiply that by 13, and what happens? Those 13 will cancel or eliminate each other, and we have 3x over 1. Any number divided by 1 is equal to that same number, 3x. Then we take that whole number. One other mistake that students make is that they neglect to multiply the whole number by the common denominator. So they just put down 120. But we multiply 120 by 13 because the entire equation has to be multiplied by 13. So multiply that by 13, we get 1560, and no doubt we have that fraction to multiply by 13 also, in which case those 13s will eliminate each other, and any number divided by 1 is equal to that same number. And what do we know? We have this plus sign that needs to be replaced here, and we have this equal sign that needs to be placed there. And we need to go further in solving the problem for x. Accumulate the x's on the right hand side by subtracting 3x from both sides. 3x will be eliminated on the left hand side, and on the right hand side we have 8x minus 3x is equal to 5x. So we subtract 3x from this side, subtract 3x from this side. 3x will be eliminated from this side, and on this side we have 8x minus 3x is equal to 5x. No doubt we also will have this 1560 on that left hand side. We are not done yet. Let's continue on the next slide. Let us finish up on the next slide. On the right hand side, x is being multiplied by 5. We will eliminate 5 by dividing by 5 on the right hand side. To keep the equation balanced, we will divide by 5 on the left hand side also. We need to eliminate this 5 that is being multiplied by x. We will eliminate that 5 by doing the opposite of multiplication. The opposite of multiplication is division. We will therefore divide by 5. But we cannot do that on one side of an equation only. We will have to do that on both sides. So let us go straight ahead and divide both sides by 5. 5 will be eliminated from that right hand side, and when we divide by 5, 5 and 2 are related, so it is the same thing or quite similar to multiplying by 2 and making minor adjustments. So if we multiply this number by 2, what will we get? 6 2 is 12, and then we have 15 times is 30. And of course we need to make use of the one that was carried. So we should have 312. Let's see if that is what we get. There it is. 312. 5 is eliminated from the right hand side, and on the left hand side we have 1560 divided by 5, which is equal to 312. We also rewrite the final answer with x on the left hand side. So 312 is equal to x. Therefore, x is equal to 312. What do we know? We are just going back into time a little bit. Remember when we multiplied the fraction by x and x found itself in the numerator of the fraction? Well, I hope that no one will consider that to be any form of magic. Multiplying a fraction by any number or by x, and x found its way into the numerator. As a matter of fact, one common mistake that students make is that if they are multiplying by x, they take x and multiply in the numerator, and they take x and multiply in the denominator, which is, of course, doing nothing at all to the fraction because the x's will cancel in the end. So we are exactly where we started from. But why then do we just place this x in the numerator? And why can we do that again? Let us see. Remember that x is a fraction with denominator equal to 1. So there we have it written, x as a fraction with the denominator is 1. Multiply the fraction by multiplying the denominators and multiplying the numerators. So this x is a fraction, x over 1. Multiply these two by saying what? 2 times x, 2 times x, and multiplying the denominators, 13 multiplied by 1. So 2 times x is 2x, and 13 times 1 is 13. So we have 2x over 13. Alright, and we can take it for granted that if we multiply by a whole number, it has the same effect of taking that whole number and multiplying in the numerator. Why? Because a whole number has a denominator of 1. The numerators are multiplied together and the denominators are multiplied together with the denominator of the whole number being 1. It does not change the denominator, but the numerator is changed. a sum of money was shared according to the given ratio. The largest share is $1,200 and must therefore be associated with the largest number in the ratio. So the largest share is $1,200, and of course if it is the largest share, it has to be associated with the largest number in the ratio. Right. And we have that sum of money to be shared, and the largest share is $1,200, and see, we are linking that up with the largest number in the ratio appropriately and also sensibly. Let us use a factor of association, which is what we will do well to get a hold of, because it was not used in any extensive way in this tutorial. So let us use a factor of association between 5 and 1,200. So we need to know how is 5 related to 1,200. Why? In order that we can cause the other numbers in the ratio to be related to their respective amount of money in the same way. So let us use a factor of association between 5 and 1,200. 1,200 divided by 5 is equal to 240. Therefore, 5 times 240 is equal to 1,200. So that is the factor of association. So we determine our factor of association, that is, we are determining a number that we can use to easily make a transformation from 5 to 1,200. That number will be used to make the transformation between 3 and its associated share, and also between 2 and its associated share. That number that we determined was 240. Therefore, if we say 5 times 240, we get 1,200. And if we say 3 times 240, then that will be the share associated with that. And we will say the same for 2 times 240. There we go. It is as easy as that. Making use of simple associations and simple common sense and logic may help us in getting our ratios problem solved without too much problems. Right there we have A's share, because the problem stated that we need to determine A's share. So right there we have A's share, and the sum of money shared may be found by adding the individual shares. So add 480 plus 720, no doubt. Add that to 1,200, and the total is $2,400. What do we do next? In finding the percentage that B gets, one may think immediately to place B's share, which is 720, over the total. That is how we find a particular percentage of a total. We place the amount over the total and multiply by 100. And that is done in the usual way of finding the percentage. The amount spoken about over the total amount and multiply by 100. That's all. And then, if anything, we may reduce the fraction. And here, we may reduce the fraction by a common factor of 100. And we will do that by striking off 2 zeros in the numerator and also striking off 2 zeros in the denominator. Then we may go ahead and reduce by a common factor of 24. Well, you may go by 2, then by 3, then by 2. But we know that 24 can go into 72 without using a remainder. And 24 into 72 is 3. But do not forget that 0 here. So 30. And 24 into 24 is equal to 1. So the answer is 30%. Very nice. However, we will take another go at the problem in which we solve parts 1 and 2 from a typical ratio application perspective. So we will take a second look at the problem and see other methods that we may use to solve the problem. Especially that we need to determine the total amount of money shared, and it is associated with the total number of units into which the sum of money is shared. Let us find the total number of units. So take another go at it. On this occasion, we are making use of direct ratio application. We will need, as it said, especially that we need to determine the total. We need, therefore, to determine the total number of units. No problem. And we get 10 units. When we add those, we know already that 5 units are associated with $1,200. Associate them. 5 units associated with 1,200. How do we know that? Because it says so in the statement of the problem. A sum of money was to be divided among A, B, and C in the ratio 2 to 3 to 5. The largest share amounts to $1,200. Which one of these represents the largest share? Well, which one of these is the largest number? 5 is the largest number. It is therefore associated with the largest share. No harm done. Okay. We may find the size of 1 unit by dividing both sides by 5. When we have a ratio problem and we can find the size of 1 unit, then we can find the size of any other number of units. Because all we need to do is take that 1 unit and multiply it maybe 8 times, maybe 15 times, maybe 3 times. But in this particular case, we will see the number of times that we need to multiply that single unit. But first, let us find the size of 1 unit. 5 units are equivalent to $1,200. So we may find the size of 1 unit by dividing both sides by 5. 5 into 5 is 1 unit. 5 into 1,200. All we need to do when we are dividing by 5 is double and take off one of the zeros. So double 12, we get 24. And take off one of the zeros, so we have 24 followed by a 0, 240. It is as easy as that. So 1 unit is equivalent to $240. In order to find the total and A's share, we multiply the size of 1 unit by 10 and 2 respectively. Now where did that 10 come from? We said in order to find the total is associated with 10 units. Therefore, we have the size of 1 unit. To find the total, we need to multiply that by 12. And no doubt, A's share is this one, which is equivalent to 2 units. So we will multiply that. We need to multiply that by 2 in order to determine the amount of money that is equivalent to A's share. And that we have done right here. Do not forget the total. We need to find the total. The total is associated with 10 units. The size of 1 unit is $240. Therefore, we need to multiply this $240 by 10. And no doubt, we do a similar calculation for A's share. If we had our eyes open, then we could have seen a simple way in which we could have found the total. Notice that it is associated with 10 units. If we had our eyes open, then we could have seen a simple way in which we could have found the total. Notice that it is associated with 10 units. Let's go. 10 units. That's the total. No problem. We know already that 5 units are associated with 1,200. How do we know that? Because we are told in the statement of the problem that the largest share amounts to 1,200. The largest share is responsible for these 5 units, and that is associated with $1,200. So we know already that 5 units are associated with $1,200. How does that make the problem simpler? Since 5 is a half of 10, then this share is a half of the total. But let's see what we have here. Since 5 is a half of 10, then the share associated with 5 units must be a half of the total share. The total share, which is of course 10 units, is therefore twice the share that is associated with 5 units. Well, that is plain. If we have the total is 10 units and we have a share that is 5 units, that means this share that is 5 units is a half of the total. Therefore, the total must be 2 times the share associated with 5 units. That share associated with 5 units is $1,200. Therefore, 10 units must be twice that, which is $2,400. And it is as easy as that. So if we kept our eyes open, keep an open eye, keep an open mind, then we could have seen how much simpler the solution of the problem could have been. Also, we could have made use of a simpler calculation in finding the percentage represented by B's share. So we could have taken a simpler approach. Also, in finding the percentage associated with B's share. B's share is represented by 3 units, and the total is represented by 10 units. We therefore need to determine the percentage represented by 3 out of 10. 3 out of 10. That is B's share. B is the one with the 3, and the total is 10. Well, the total is represented by 10 units. So it is 3 units out of 10 units times 100, and no doubt we just reduce by a common factor of 10. And we usually do that from primary school by just striking off a 0 in the numerator, striking off a 0 in the denominator. 3 times 10 is 30, and that's all there is to it. This turns out to be a bit simpler than using B's share. That turned out, I can see if I can remember, $720. So it turns out to be a bit simpler than using B's share, which is $720 with the total of $2,400. So I am saying that take an extra 5 seconds to examine the problem rather than an extra 2 minutes solving it. And that we could have done if we took a second look at it to realize that the share that was given is actually half of the total, so the total must be twice that. And also the share is 3 out of 10, which is the same as 720 out of 2,400. But it is easy to say 3/10. And of course, we did not even have to go through this length to multiply by 100 and reduce by a common factor of 10. We know that 3/10 is 30%. It is as easy as that. What about this one? The entire length of the string is 64 centimeters because it says here that a piece of string is 64 centimeters long, and it is divided into 3 pieces in the ratio 1 to 2 to 5, as we have it right there. And we need to calculate the length of the longest piece. So the entire length of the string is 64 centimeters, and we need to determine the length of the longest piece. So let us find the total number of units associated with the piece of string, because the entire length is 64. So we need to determine the number of units associated with the 64. That's a good way forward, considering that the entire length is given to us. 8 units as we have there. 1 plus 2 plus 5 is equal to 8. Therefore, 8 units are associated with 64 centimeters. 8 units are associated with 64 centimeters. And we will go on and on, but it will still be the same. Find the size of 1 unit. We may find the size of 1 unit by dividing both sides by 8. 8 into 8 is 1. That gives the 1 unit, and 8 into 64 is 8. So 8 centimeters. 1 unit is equivalent to 8 centimeters. In order to find the length of the longest piece, we multiply the length of 1 unit, which is, this is the length of 1 unit, by the number of units associated with the longest piece. So we take 1 unit, which is 8 centimeters, and multiply that 1 unit how many times? Well, the number of times that we have right here, which is being represented by the number of units associated with the longest piece. So 1 unit, 8 centimeters, multiply that by the number of units associated with the longest piece, which is 5. So 8 centimeters times 5, and that is equal to 40 centimeters, and that's all there is to it. But we are not done yet. Here is your first take on the solution of the problem as we are accustomed to from primary school. What do? Yeah, we have that 8 units for the total. In finding the largest share, we take the number of units associated with it, which is 5, and divide it by the total number of units that we have there as 8 that we have found by adding all of the respective units. Then multiply the result by the total length of the string. So that is what we are accustomed to. We take that the number of units associated with the largest share, and we place that over the total number of units and multiply that by the total length of the string, and we reduce by a common factor of 8. 8 into 64 is 8. 8 into 80 is 140 centimeters, as we have calculated before. This is a matter of saying that the largest share represents 5 parts out of 8 of the total length, which is 64. From primary school, we say of is associated with multiplication. So we say it is 5 out of 8 of 64. So it is 5 out of 8 multiplied by 64, which is saying that what we are actually finding for that longest piece is 5 parts or 5 units out of a total of 8 units of the entire length of the string. So we multiply by the entire length of the string. The numbers in the ratio are matched with the elements in the metal. We need to find the mass of the entire piece of metal. Hence, we will find the total number of units represented by the metal. So in this problem, what do we have there for that problem? A piece of metal is made from copper, zinc, and lead in the ratio 13:6:1. The mass of zinc is 90 kilograms. Calculate the mass of the metal. So we need to calculate the mass of the metal. After we have given the information that zinc is 90 kilograms, and I think that we have stated it in a very plain and straightforward way right here, because copper, zinc, and lead. So if zinc is 90 kilograms, we are sure that it is related with 6 units. So we need the entire metal. So we will find the sum of the number of units, and we have a total of 20 units. So 20 units is what we have right there. The mass of zinc is 90 kilograms. This is associated with 6 units, as we have right here. Zinc, 6 units. Zinc, 90 kilograms. So 6 units represented with 90 kilograms. And what do? As usual, we find the size of 1 unit, which is a very powerful step in solving a ratio problem. If we can find the size of 1 unit, half our problem is over. So we may find the size of 1 unit by dividing both sides by 6. 6 into 6, 1. So that's 1 unit. 6 into 90, 15 kilograms. And what do? We need to find the mass of the entire metal. And what do? We take the size of 1 unit, and the entire metal is 20 units. So it's 20 times that. 20 times the size of 1 unit. So 20 multiplied by 15, and that is equal to 300 kilogram. As easy as that. Number 5 that we have there, which is actually the problem that states that a piece of wood is divided into 3 pieces in the ratio 3:4:2. The length of the longest piece is 72 centimeters. Calculate the length of the piece of wood, which is the entire thing again. So this one is quite analogous to the one that we had before, and the analogy is very close. So go straight ahead and determine the number of units, the total number of units, and there we have that as 9. But what else do we know? The length of the longest piece is 72 centimeters, and it is 4 units. How do we know? Because the longest piece of the share, or the longest or the largest share, has to be associated with the largest number. The largest number is 4. Therefore, 4 units are equivalent to 72 centimeters. And what do? We find the size of 1 unit by dividing both sides by 4. Let's go straight ahead. No doubt, 4 into 4 is 1, so 1 unit on that side, and 4 into 72 is 18. There we have the size of 1 unit, and the entire thing is represented by 9 units. So find the entire length by multiplying the size of 1 unit by the total number of units. What is the total number of units? 9 units. Therefore, we need to multiply the size of 1 unit by 9, and we will find the length of the entire piece of wood. 18 times 9 is equal to 162. The sum of money, which is $2,500, and that is divided among 3 children, Peter, Raymond, and Queen. Raymond received half of the $2,500 that was shared among the 3 children. Raymond received half. That's easy. Divide by 2. So 2,500 divided by 2 gives 1,250, and that is Raymond's share. It is said that Peter received $312.50, and Queen received the remainder. Therefore, we may subtract Peter and Raymond's share from the total, and the remainder is Queen's share. Only 3 shares. One got 1,250, and the other one has $312.50. So, how much does the other have? All we need to do is subtract those 2 from the total, and what remains is the share of the other one that is missing. No problem. So Queen's share will be $937 and 50 cents. Pretty straightforward. However, we should have seen that if Raymond receives half, then the other half will be shared between the other two. Therefore, Queen will get that which remains of the other half after subtracting Peter's share. Well, if one person got a half of the amount, which is this, then the other half must be shared between the other two. Of course, the other half must be the same as the first half. So the other half, which is the same as 1,250, must be shared between the other two. Therefore, we will take that 1,250 and we will subtract that $312.50. So the subtraction should have been from the half rather than from the whole. And no doubt we could have received our answer in a simpler way. Find the ratio in which the money is shared by simply writing the amounts given to them as a ratio. It is as easy as that. One got 1,250, the other got $937.50, the other one got $312.50, and we need to determine the ratio in which the money was shared. Put those numbers down in a ratio. That would have been the correct answer. However, we will opt to write it in the simplest form. So the problem did not require, or the statement of the problem did not require, that the ratio be written in its simplest form. We may do it by dividing each number by the smallest one. In preparation for the other section, now, when we are writing a ratio in its simplest form, we do not just jump and take the smallest number and divide into all of them like that. That might not reduce it to its simplest form. It turns out that it works in this particular case. But in the event that we have to do it, we will choose the largest number, which is the highest common factor of these three, and we will divide each one of them by the highest common factor. In this particular case, it so happens that the highest common factor is actually one of these numbers, the smallest one. Therefore, that makes the transition very easy. And it makes it a bit simpler to the extent that we do not have to search very hard for the highest common factor. It turns out that using this one does work, which is the smallest one. But in the future, in the case that it does not happen, search for the highest common factor and use it. So the ratio turns out to be 4 to 3 to 1. To find Peter's percentage, divide the number of units that he received in the ratio, which is 1, by the total number of units in the ratio, which is 8, 4 plus 3 plus 1, and multiply by 100. Alright, let's go again. To find Peter's percentage, what do we do? Peter gets 1. Peter gets 1 out of a total of, at these, we get 8. And that we multiply by 100. And what is the answer? We know that a half is 50%. We know that a quarter is 25%. What is a half of 25? 12.5%. That means 1/8 is 12.5%. And we should have remembered that from primary school. So, from primary school, we know that 1/8 is 12.5%, 12.5%. Therefore, the percentage that Peter got is actually 12.5%. And that is much easier done by using the numbers that we have in the ratio rather than actually taking Peter's share, then divide it by the total, which turns out to be, well, we got it right there to be 2,500. So we would have to place this $312.50 over 2,500, and then we multiply by 100. But we do not have to do that, because everything will be in the same proportion as represented by the ratio. Therefore, we may use Peter's part of the ratio, which is 1, and we may use the total number of units in the ratio, which is 8. And that can make our work much simpler. Well, it is said that the other two individuals got twice as much as John. So let us go straight ahead with this one. It is easier to write the ratio if each of the girls received twice as much as John. So let us say that John received 1 unit. Each of the girls receiving twice as much as John should therefore receive 2 units each. That's very nice and easy. Or let us take it out a little further. Let us say that 5 units represent John's share. So let us say that. So let us say that John received 5 units. If John received 5 units, then each of the girls receiving twice as much as John should therefore receive 2 times 5, which is 10. So 10 units each. So John would get 5, the other 10, and the other 10. But John, we are trying to make it as simple as possible by saying that John received only 1 unit. Therefore, each girl received 2 times 1, which is 2 units, and the other 2 units also. So that is our ratio. No difficulty. And we are going straight ahead to find the total, because the total has to play some role here. What it is said. What is said about the total? Share $150 among John, Mary, and Sarah, so that each of them get, or each of the girls, so that each of the girls receives twice as much as John. Calculate the amount of money John received. Calculate the amount of money that John received. I like this one also. Calculate the amount of money that John received. I'm thinking that everyone will not have any difficulty with this one, because John received only 1 unit. And one of our greatest intermediate goals in solving a ratio problem is to find the size of 1 unit. So let's go straight ahead and do that. So 5 units are equivalent to $150. And as sure as night follows day, or the other way around, if you please, we are dividing by 5 in order to find the size of 1 unit. So 5 into 5 is 1, and 5 into 15 is 3. But do not forget this 0, 30. No need to go any further. John's share is represented by 1 unit. That is shown to be $30. So we will not go any further to find John's share because it is represented by 1 unit, and we have found that already. How nice. Now we are required to go straight ahead and express John's share as a fraction of the total amount. So John's fraction is equivalent to 1 unit out of 5 units. 1 unit for Mr. John out of 5 units. And that is John's fraction. It cannot be any simpler. John's fraction is 1 out of a total of 5. That's easy. We do not have to calculate the shares in order to determine any fraction that may be associated with it. Irrespective of the amounts, they will be in the same proportion as the numbers in the ratio. We may therefore use the numbers in the ratio to calculate those fractions. So, no need to go all around in order to calculate each person's share and then use it as a fraction of the total. No, they will be in the same proportion as the numbers in the ratio. Therefore, we can use the numbers in the ratio instead of the shares, and also use the total of the numbers in the ratio in the place of the total that is being shared because of that direct proportion. No problem with that. So let us go straight ahead. Mary received 2 units. But why are we saying that? Because it says express Mary's share as a fraction of the total amount received by John and Sarah. So let us do that. Mary received 2 units. The total number of units received by John and Sarah, we add them together, 1 for John, 2 for Sarah, 3. The fraction may therefore be easily written as 2/3. That's all there is to it. We do not have to determine all of the shares and putting the result over whatever share. We did not have to go and find the actual monetary value. We need only to make use of the numbers in the fraction because they are in the same proportion as the shares. So we do not have to go there. Final problem in this section. The problem contains quite a bit of information that we will do well to ignore. So let us ignore the unnecessary information. Well, it says here that Lily, Margaret, and Nancy were each left $12,000 in their uncle's will. Lily decided to spend her money on clothes, holidays, and decorating her flat in the ratio as we have there. How much did she spend on decorating her flat? Therefore, it does not matter how much money Lily got and what she did with it. Well, it does not matter how much money Margaret got and what she did with it. And it also does not matter how much money Nancy got and what she did with it. The only thing that matters is that Lily's amount is $12,000 and she decides to use it according to the ratio that we have there. So we will ignore that Margaret exists, ignore that Nancy exists, and ignore the amount of money given to them. Just focus on the fact that Lily got $12,000 and she decided to use it according to the ratio that we have right there. And it is said then, how much did she spend on decorating her flat? And the last number is associated with decorating her flat. So there we have a total of 16 units. Decorating her flat will be 7 out of 16. So find how much money is spent decorating her flat by taking the number of units associated with it. Decorating her flat, 7 units, and dividing it by the total number of units, 16. Multiply the result by the total amount of money. So 7 out of 16 times the total amount of money, and what do we get? Well, what we get when we reduce by a fraction of 16. Well, what do we get when we reduce by a common factor of 16? 16 into 12,000 is 750. Nice to say that 16 into itself is 1. And then we go straight ahead and multiply that 7 by 750, and we get 5,250. And I am saying that we could have done that mentally by hanging on to this 0 that we will place right here. And then we say 75 times 7. That's very harsh, but not really, because 7 times 7 is 49, and we may treat this as 7.5, and a half of 7 is 3.5. So 49 plus 3.5 is equal to 52.5. So we have the 525 there, and do not forget the 0. It is as easy as that. We can multiply mentally for some numbers that look really harsh. So there we are, multiplying 750 by 7, and at the end we say that we are taking 7 parts for decorating the flat out of a total of 16 parts of the total sum of money. So 7 parts are used to decorate the flat out of a total of 16 parts. Right, so that is a fraction, the fraction of the total amount of money. So we multiply by the total amount of money, and that is all there is to it. We may take another approach in which we make use of the amount of money represented by 1 unit as usual. That is our favorite. So we know that all the units together is a total of 16 units. And what do? The total is $12,000 and is represented by 16 units. There we have it. 16 units, $12,000. And as usual, we may find the size of 1 unit by dividing both sides by 16. 16 into 16 is 1. And then, of course, we know already from the previous slide that 16 into 12,000 is 750. And we find the amount spent on the flat by multiplying the size of 1 unit that we have right here as $750 by the number of units associated with the flat. How many units are associated with the flat? 7 units are associated with decorating the flat. We multiply by 7. What do we multiply by 7? The size of 1 unit. The size of one unit is 750. We have determined that from right here. And the number of units associated with decorating the flat is 7. So 7 times that, and the result is no doubt the same as before.